Platform Hogan from UC Santa Barbara, visualizing with Deutschland panoramas, with photography by Pablo's Dog and BM LSB 69. You may be familiar with this image, dubbed the Black Swan, which supposedly proves the Earth cannot be a globe. It's from this video by BM LSB 69 of petroleum platforms off the coast of Santa Barbara. We'll return to this at the end of the video. Meanwhile, YouTuber Pablo's Dog, who has some platforms in his YouTube avatar, has been filming other platforms and Southern California coastline by panning his tripod to record the imagery. His channel is full of these pans taken from a parking lot at the University of California at Santa Barbara. I noticed something interesting to the left of one such platform, Platform Hogan, shown here in a photo by the Marine Corps. I decided to extend the line of sight from UC Santa Barbara past Platform Hogan into the hills between Oxnard and Los Angeles. The first high point is what Pablo's Dog calls Ventura Overhead, followed by Adventist Hill and what I'm calling Westlake Hill. Here's a topographic view of the area I'm calling Ventura Hillside and Ventura Slopes, along with a 3D render of the area from Google Maps. Further along the line of sight is Adventist Hill, north of Casa Conejo. And here's a render of it from in 3D from Google Maps. Still further is an unnamed high point north of Westlake, which I'm calling Westlake Hill. Here's a picture of it from Google Street View. So let's build an orthographic side view of this line of sight. To make things easy to see, I'll exaggerate the heights by 100 times, as is commonly done in elevation profiles. Otherwise, entire mountains will be reduced to pixels. So we'll start with our viewer height with elevation 15 meters above sea level at Lot 6 of UC Santa Barbara. At 28.7 kilometers, we have Platform Hogan, 71 meters tall. Then we have Ventura Hillside and Ventura Slopes at 49 kilometers. Next is Adventist Hill at 85 kilometers, and ending with Westlake Hill at almost 100 kilometers from UC Santa Barbara. Now let's analyze what we'd expect to see if the Earth were flat. First, our line of sight from UC Santa Barbara will show Adventist Hill to be the same visual size as Westlake Hill. Next, Platform Hogan will appear to be about as tall as Ventura Slopes, with the far high points of Adventist Hill and Westlake Hill appearing over twice as tall as Ventura Slopes, shown in our field of view. So now we're going to turn to Deutschland panoramas to actually create the visualization for us, with the settings dialed to RC1 for flat Earth. Basically, this forces level to be horizontal, exactly as with a flat Earth. And here's the result. Just as we pointed out earlier, Adventist Hill appears to be visually the same height as Westlake Hill, and both are over twice as tall as Ventura Slopes. Deutschland only visualizes landforms, not artificial structures, so we'll do a bit of math to add Platform Hogan to the picture. We need a sea level view of the platform, but the closest one I could find was this photo by Hudson Mayfield of an unnamed Santa Barbara rig, along with this diagram of Platform Holly nearby. To size it appropriately, we'll measure the visual width of the platform, perpendicular to our line of sight, and plug it into the angular size calculator from 1728.org. We find it to be almost exactly 1/10 of a degree in angular width. Now let's return to the Deutschland image and take note of the azimuth markings across the top and measure 1/10 of a degree to size the platform. To accurately place Platform Hogan, we'll again use the azimuth scale, but we need the azimuth of the platform from the parking lot at UC Santa Barbara. So here we're using the EnviraJ website and the latitude and longitude of UC Santa Barbara's parking lot and Platform Hogan. We find the azimuth is 105.93 degrees. This allows us to accurately place Platform Hogan. And here's the final visualization. What we would expect on a flat Earth where level equals horizontal. But what should we expect on a globe Earth? We'll turn to Metabunk's Earth Curve calculator and basically subtract out refracted hidden heights from our orthographic view. Here are our 4 targets. We'll subtract 13 meters for platform Hogan, 79 meters for Ventura Overhead, 333 meters for Adventist Hill, and 484 meters for Westlake Hill. Returning to our orthographic diagram showing the elevation profile above sea level, we'll subtract out the hidden heights. Notice that this time our line of sight to Adventist Hill is about halfway between the heights of Ventura Hillside and Ventura Slopes, while Westlake Hill is completely hidden by Earth curvature. Let's return to Deutsche panoramas and this time use the defaults. And here's the result. We do in fact see Adventist Hill appearing between the heights of Ventura Hillside and Ventura Slopes, just as we predicted. But what about platform Hogan? Returning to our diagram of platform Holly as a stand-in, and knowing 13 meters or 43 feet will be hidden, we can use a green rectangle to cover the base. And we'll place platform Hogan at the correct azimuth of 105.93 degrees. So here's the final image as expected on a globe Earth. So as a reminder, here's what we would expect on a flat Earth, and here's what we'd expect on a globe Earth, and here's what Pablo's dog filmed from UC Santa Barbara. There are 2 possible complaints. One is that I'm using globe refraction as a get-out-of-jail-free card, and the other is that I'm cherry-picking this one image because it best fits my narrative. Well, Deutsche can be used to simulate the globe with 0 refraction also, and it looks like this. So compared to the one with standard refraction, which makes distant objects appear slightly higher. The second complaint is that I'm cherry-picking. I'll let you be the judge, but let's first review what astronomers call seeing, which is the optical quality of the atmosphere. In Pablo's dog's footage, the atmospheric conditions varied greatly day to day, so it might be wise to select images that show the least amount of distortion. I was inspired by Bobby Shafto's video where he took the opening vista from many days of Pablo's dog footage of Mesa Lane towards Muscle Shoals, and he put them in a montage. So let's actually go through 40 days of footage from Pablo's dog and see how platform Hogan and the surrounding landforms appeared. Keep an eye out for mirage refraction effects, as well as the optical quality of the platform itself, whether it appears sharp or blurry. So, what of BMLSB's 69's footage of platform's Hill House and habitat? It turns out that he too went out on another day with different seeing conditions, and he shot this image, showing the amount of horizon obstruction as predicted by the globe Earth. Special thanks to my channel supporters Dora, Johnny, and Luke. Rest in peace, Jim Jackson. And as always, please be kind to each other in the comments. Bye!